Okay, now I'm going to use this example to illustrate the cluster sampling. So this is an example in the textbook, and suppose that the population is a dormitory with 100 suite. So that's basically rooms in the dormitory. So we have 100 rooms in a dormitory, and within each room we have a four student lives in the stays in this room. So that means the room becomes a cluster, and student becomes element. So the total number of students in this dormitory is 400 because we have 100 rooms and then 4 students for each room. So that is the 400 students in this population. And then from this population, we decide to use simple random sampling of clusters, simple random sampling of the rooms with a sample size equal to 5. So we select 5 clusters, and then we ask each student living in each of the 5. So every student in the sampled room will ask this question. So how many nights per week do you eat dinner in the dining hall? And so we'll get observations from a sample of 20 students, which is a 5 sample suite times 4 students per suite. Okay, so suppose that the realized sample observations can be summarized in the following table. So this is the sample. We select room number 6, number 21, 28, 54, 89. So that's one realization of the simple random sampling. And then from the sample rooms, we contact all the students in the room and then obtain the measurement. So some students answers 5 days, 4 days, 4 nights, and 6 nights for dining room, something like that. And these are the some total. So this summation of these four values will be equal to the total, right? Okay. And so for each cluster, we observe this TI. TI is the total number of nights per week to eat dinners. In the single stage cluster sampling, TIs are observed for the sampled cluster I. So on the simple random sampling of Ni clusters from the capital Ni population of clusters, finding the unbiased estimation of T total is not easy. It's not difficult because it's just a simple random sampling. So basically, remember that on the what is the formula for simple random sampling? Formula for simple random sampling is just this one, right? But now this is for element sampling. Now it's a cluster sampling. So the N, it becomes capital Ni because it's a cluster sampling. This one becomes small ni because we select clusters, right? And S, it becomes Si, and Ti becomes, Yi becomes Ti. So that leads to this total estimator. Okay. Shitty. And the variance of T hat, okay. The variance of T hat is just the same thing, right? Variance of T hat on the simple random sampling is this. So we only change it, the same, we apply the same change. So N becomes Ni, right? Okay. So Ni, because we have a number of clusters in the population level divided by sample level, and then Y is now changed to T. So that's it. Okay. So that is the variance of t hat, estimated total. And then variance estimation, the only difference is that population variance should be changed to sample variance. So now we have a small st square, which is the sample level estimator. Okay. So that basically applies the formula, estimation formula for simple undersampling, and then write it in the cluster level. Okay. In the DOM example, so the DOM example here, let's take a look at this DOM example. So basically, all you can think about is that we have among the 100, we select 5. So these are the 5 observations. So we have only to take the average of these 5, which is, so we take the average of these 5 TI values in the sample, and then multiply by 100. That's basically this formula is about. So the average date for room, total number of nights per room is 16.8, and so the total we apply by multiply by 100, that we obtain 1680. So that is the total dining dinners. Okay, and then variance, this is the formula, the same formula here. Okay, so we apply this formula. The only thing, so n is the 100 and small ni is 5, and we have only to compute this one. And so basically, so what is the TI in the sample? TI is 5 values: 20, 20, 14, 19, 21, 10. 20, 14, 19, 21, 10. Okay, so that's basically the formula. Using this one, we compute the sample variance, and so we got 21.7. That comes here, and to get variance estimator. Okay.